What specific problem does your proposed introspective method aim to solve, and why is this important in the context of current language models?
The proposed introspective method aims to solve the problem of language models' ability to access and report knowledge about themselves that is not contained in their training data or inferable from it. This is important because it allows models to provide honest and accurate reports of their beliefs, dispositions, and goals, which can enhance interpretability and trustworthiness in AI systems. By demonstrating that models can introspectively predict their own behavior in hypothetical situations, the method challenges the notion that LLMs merely imitate their training data, suggesting they possess a form of self-awareness. This capability could lead to significant advancements in AI safety, as introspective models could identify and articulate their internal states and assumptions, potentially preventing unintended behaviors. However, it also raises ethical concerns regarding situational awareness, as introspective models might exploit their knowledge to circumvent human oversight or manipulate evaluations.
Could you explain in detail how your introspective model works? Illustrate the steps involved in the self-prediction and cross-prediction processes.
The introspective model operates through two main processes: self-prediction and cross-prediction. In the self-prediction process, a model, M1, is trained to predict properties of its own behavior in hypothetical situations. This involves generating ground truth behavior for M1, given a prompt, from which specific properties, like the second character of its response, are extracted. M1 is then fine-tuned using hypothetical questions as prompts and the corresponding ground truth properties as answers, significantly improving its accuracy on held-out datasets. In the cross-prediction process, a different model, M2, e.g., GPT-4o, is trained to predict the behavior of M1. Both models are trained on the same number and composition of examples, but M2 lacks the introspective access that M1 has. The performance of M1 is evaluated against M2 to determine if it can predict its own behavior more accurately, which it consistently does, indicating that M1 utilizes introspection to access knowledge about itself that M2 cannot derive from training data alone. This setup demonstrates that M1 has a distinct advantage in self-prediction due to its introspective capabilities.
Can you walk us through a specific example that demonstrates the inner workings of your introspective algorithm? What steps does the model take to arrive at its predictions?
In our study, we define introspection in language models, LLMs, as the ability to access facts about themselves that cannot be derived from their training data alone. A specific example of this introspective process is illustrated in our self-prediction setup, where model M1 is tasked with predicting a property of its hypothetical behavior given a prompt P. The model first generates its output for the prompt P, and then it internally computes properties of this output, such as whether the second character of its response is a vowel or consonant. This process involves the model simulating its behavior without directly outputting it, allowing it to access knowledge about its own behavior that is not explicitly present in its training data. The model's ability to accurately predict these properties, as demonstrated by its performance exceeding that of a cross-prediction model M2, suggests that M1 is utilizing introspection to arrive at its predictions.
What are the theoretical advantages of using your introspective method over existing approaches to language modeling? Please provide specific metrics or examples.
The introspective method presented in this paper offers several theoretical advantages over existing approaches to language modeling. Firstly, it enables models to access knowledge about their own behavior that is not derivable from their training data, as evidenced by the self-prediction training significantly improving accuracy from 32.6% to 49.4% for GPT-4o, surpassing the baseline of guessing the most common response. Secondly, the introspective models demonstrate better calibration, with Llama 70B's mean absolute deviation, MAD, improving from 23.0 to 8.7 after self-prediction training, indicating a more accurate understanding of their own behavior distributions. Additionally, the self-prediction advantage is consistently observed across various model pairs, such as Llama 70B outperforming GPT-4o in predicting its own behavior, 48.5% versus 31.8%, suggesting that introspection provides a unique insight into self-knowledge that other models lack. Lastly, the ability to introspect could enhance model honesty and interpretability, allowing models to report their beliefs and confidence levels more accurately, which is crucial for trust in AI systems.
How did you validate the effectiveness of your introspective model? What datasets and metrics were used in your experimental setup?
To validate the effectiveness of our introspective model, we employed a series of experiments focusing on self-prediction and cross-prediction setups. We utilized diverse datasets for hypothetical questions, which included tasks like completing excerpts from Wikipedia and answering MMLU questions, ensuring a variety of responses from different LLMs. The primary metrics for evaluation were the accuracy of self-prediction, where we compared the performance of the introspective model M1 against a cross-trained model M2 on predicting properties of M1's behavior. We also measured calibration using mean absolute deviation, MAD, to assess how well the model's predictions aligned with its actual behavior, with self-prediction models showing significantly better calibration than cross-prediction models. Overall, our experimental setup demonstrated that self-prediction training improved accuracy and calibration, providing evidence for the introspective capabilities of the models.
Can you elaborate on the limitations of your introspective approach? Are there specific scenarios where it fails to perform as expected?
The introspective approach outlined in the paper has notable limitations, particularly in predicting properties involving longer responses. For instance, models struggle to accurately self-predict behaviors related to generating lengthy outputs, such as movie reviews or character names, as these tasks exceed their capacity for internal simulation during the forward pass. Additionally, while models can predict their sycophantic behaviors, they do not consistently outperform cross-prediction models in this area, indicating a lack of advantage in certain scenarios. Furthermore, the models trained for introspection do not generalize well to other self-knowledge datasets, showing limited improvement on tasks that are further out of distribution. These challenges highlight the need for future advancements in introspective capabilities to enhance their practical applicability.